A patient is to receive 7,500 milligram of dilaudid intravenous push every hour as needed to control pain. The vials to be used are 2 milligrams per milliliter. How many milliliters will the patient receive? To answer this question, we need to have our answer in milliliters. We'll set that as our goal. To begin the process of dimensional analysis for this pharmacology problem, we will begin with the doctor's order, shown here, and expressed as a fraction with a denominator of 1 for an equivalent value. Next, we need a conversion factor fraction such that we are able to cancel out common factors, in this case milligrams, to proceed in converting this to milliliters. In the problem, it states that 2 milligrams is equal to 1 milliliter. Taking these equivalent values and placing one in the denominator and the other in the numerator gives us a conversion fraction with a value of 1, which multiplying by 1 does not change an expression's value, but will convert from one unit to the other. In fraction multiplication, common factors in the numerator and the denominator cancel out, since they are equal to 1. Continuing then, we'll multiply numerators together for the new numerator, multiply denominators together for the new denominator. Seeing that our unit is in milliliters, which was the goal, the last step then will be to perform the division. 7,500 divided by 2 means that this order now in milliliters is equivalent to 375 thousandths. In this next problem, the prescription is for 12.5 milligrams of Zyprexa orally once per day. Available are 2.5 milligram tablets. How many tablets are needed per dose? To answer the question, we need to convert that order into tablets. We'll set that as the goal. Beginning with the doctor's orders as a fraction, we have 12.5 milligrams over 1. Our conversion fraction will need to have milligrams in the denominator so that we can cancel out the current unit the prescription is in. The problem gives us a relationship between milligrams and tablets shown here. Taking each value and placing it in a fraction, we now have our conversion factor that allows us to cancel out the common value in the numerator and the denominator. We see that the unit remaining is tablets, which is what we need to answer this question. To continue this problem, we'll multiply numerator and denominator values together. Last step, do the indicated division, numerator divided by denominator, for a final answer of 5 tablets for an equivalent form of the prescription that was given in milligrams originally.